Welcome to MyProjectBazaar.com. Now we discuss about the product for energy and area efficient 3 input XOR XNOR with systematic cell design methodology. Next we see the abstract for the product. With the rapid growth of portable electronic device, it's becoming a critical challenge to design low power high speed circuits that occupy small chip area. Therefore, a well-organized design methodology can be regarded as a strong solution for the challenges. It's not a try and error driven, which means that it systematically or deliberately aims to the design goals. It also picks circuit component visually and does not postpone the determination of the circuit characteristics after simulation. Cell design methodology has been presented the design some limitation functions for such as 2 input XOR and XNOR and carry inverse carry in the hybrid CMOS style. In this brief, we propose the 3 efficient 3 input XNOR circuit as the most significant blocks of the digital system with a new systematic cell design methodology in hybrid CMOS logic style. SCDM, which is an extension of CDM, plays the essential role in designing efficient circuit. At first, it is deliberately given the priority to general design goals in the basic structure of the circuit. This structure generated systematically by employing the binary addition diagram. After that, concerning high flexibility in this design targets, SCDM aims to specific ones in the remaining 3 steps, which are wise selection of basic cells and aimed mechanisms as well as the transistor sizing. In the end of the output, they perform well with supply voltage scaling and their critical path contains only 2 transistors. The SCDM divides a circuit structure into main structure and optimization correction mechanism. In the main structure, it consists features including the least number of transistors in a critical path and fairly balanced output being power ground free and symmetry. The mechanism have a duty of completing functionality of the circuit, avoiding any degradation on the output voltage and increasing the driving capability. Next we see the flow diagram for the product. First we apply the input voltage VDD and ground section based on our input section for overall 3 input XOR XNOR CMOS design. This design consists of the X0 based CMOS design and X07 based CMOS and X010 based CMOS design. The kind of designs to be placed in XNOR and XOR based functions at the same CMOS design circuit. This circuit to analyze the how many variations on output wise and input wise voltage variations and power variations based on the performance analysis, and to analyze these 3 kind of things, and if the conditions to be satisfied in X0 based CMOS design function, then that's the XOR XNOR based design to apply the single bit full adder architecture, and these kind of CMOS design to satisfy the full adder performance, then we implement the 8-bit full adder CMOS design for our overall output. Finally, we calculate the output simulation graph for 8-bit full adder CMOS design based process. So this process to reduce the overall circuit diagram and circuit area for adder circuit complexity, because adder consists of more kind of circuits and more kind of transistor count, and it consumes more kind of leakage power for our overall adder function designs, and carry propagation time to be more for conventional adder design. So we implement this kind of CMOS design to be placed in our adder circuit to improve the adder performance level and to increase the single bit and 8-bit based full adder sum and carry output generation also. This sum and carry output to be full-fledged for our output variations, and to reduce the leakage power for O, and also to reduce the overall power consumption compared to the conventional ripple carry adder, and to produce the head adder structure to implement our 3 input XOR based X04 based CMOS design. Finally, we see the output for the product. This is the output simulation based process. This is the truncated channel designed to produce the output for our final XOR based model for XNOR and XOR based model based designs. These kind of cells to develop the XOR based X04 and 510 logic for present in, and to implement the single bit full adder function for a cell 3 model and cell 4 model to represent the 8-bit full adder architecture, 8-bit adder structure, parallel head adder architecture using the XOR XNOR X04 based XOR XNOR logic. This kind of CMOS design to represents the how many less number of transistor count to placed in our X04 CMOS transistor design, and to improve the output and output voltage level to be high. This circuit designed to reduce the leakage power and to improve the adder processing performance level. These are the final output for the overall simulation designs. This output simulation to be developed based on our CMOS circuit transistor based designs. We implement the CMOS circuit based work to produce the voltage output variations and to calculate the power and delay time variation for overall 8-bit adder circuit, and compared with the previous power consumption for overall based process. This CMOS design to improve the adder performance level for the physical oriented diagrammatic representations, and to run symbol to run the output and the setup simulation to set the time period and time step, all the things to be present in our output. You just run the start simulation and to run the final output. This output to produce the T-spice and the WEdit waveform files. T-spice the running process, background running process, and the waveform edit file to produce the output variations for the voltage level. We apply the three kind of input data bits to be passing in some carry, and A, B input to be passing in every adder circuit, and the carry passing to the next input carry input. First 3-bit sum and carry output, the carry output to be passing to the next another one 3 input adder structure. This passing to the overall final output. These are the sum carry output for overall 8-bit adder circuit diagram. The output variation to be finalized equally, and no leakage power and no extra power consumption for our overall X0 based XOR and XNOR based CMOS architecture design. This is the final output for our required XOR XNOR based architecture designs.